This app helps to understand how actually average value of random sample taken from a population vary around the true population mean. So what you see here, we can change three things. We can change the standard deviation of the population. By default, it's 3. And you can see that actually the population, it's the chloride in water. So let's say we are talking about a lake, for example, and if we take a lot of glasses of water from this lake and find out how much of chloride water from each glass has, then this distribution will be normal. Average of this distribution is 100 milligrams per liter and standard deviation is 3, and then we can change the standard deviation. We will do it later. Then we can also change the sample size. You can see that by default the sample size is 5, and then we can take a new sample. So every time you run this application, the sample is completely random. So it means that these two values that you see, it's sample mean and sample standard deviation, are not the same in your case as I see it here. Now look, already now we can see that the average of our sample is larger than the average of the population, and standard deviation is smaller, right? And then you can see that the sample size is small, it's only 5 values. And all 5 values we got, they are on the right side, on the right tail of the population. So therefore the average of the sample is heavily sort of shifted to the right. If I start taking a new sample, for example, this one, you can see now we have an opposite situation. So now the average is smaller than the population average. The sample average is smaller than the population average. You can see it here. And this time standard deviation is pretty close, right? And then if I take one more, you can see that it varies randomly. Sometimes it's on the left side, sometimes it's on the right side, and so on. But it varies. Sometimes it can be pretty far away from the population mean, and sometimes it's pretty close to the population mean. So the overall idea is that every time you take a sample from your population, the sample mean is also a random number, and it will vary around the true population mean. How far it can go from the population mean? Well, we can compute this, and this is what you see here. This is what is called a sampling distribution, and it's a population-based sampling distribution. It means that I made this distribution by knowing the population parameter. So I know that average of population is this one, standard deviation is this one, so I know where to expect my sample mean. And then you can see that it's a normal distribution. So in statistics, there is a central limit theorem that tells you that average values are always normally distributed regardless what distribution the population has. So this is normal distribution, and then you can see that actually we can expect for this sample size 5, we can expect that average of sample will be around 100. It will be around the true population average. But it can go that far, and it can go that far, and it can go that far in this direction. So you can see that actually we can get any value between 95 and 105. We can get even beyond this interval, but it's very unlikely. Now we can compute not all possible values, but only, for example, 95% possible values. So I can limit this by 95% possible values, and this is what you see as a shaded area here. So shaded area gives you an interval for 95% possible values, and that's what we call a confidence interval. But in this case, it's a population-based confidence interval. You can see the computation here. The population-based confidence interval depends on two things. It's a sample size and the population standard deviation, okay? And then you can see that in this case, in 95% of the cases, so it means that if I repeat, if I take my sample many times, like hundreds of times, 95% times, the sample mean will be here. And then you can see that I already took 37 samples, and 36 out of 37 had average in between, and only one had average beyond this interval. And then you can see it gives me 97.3%. The meaning of this 95%, it means that if I repeat it many times, like for example, thousands, 10,000 times, so up to, I don't know, infinite amount of times, then this percent, how many samples will have average within the interval, and it will be close to 95. So in this case, you can see that it's 98%, but again, it's just by chance. If I keep taking new samples, then this value will be pretty close to 95%. Okay. Now, as I said, this confidence interval, it depends on two things. If we are talking about population-based confidence interval, at least, it depends on the sample size, and it depends on the standard deviation of your population. So if standard deviation is smaller, you can see that the confidence interval is also gets smaller. That's kind of natural because the overall spread of the values is smaller, right? So in this case, you can see that, for example, in this case, 95, 98, almost 99% to 101. But again, the idea is that if I repeat and if I take a lot of samples, you can see that after a while, the number of samples that are within the standard the confidence interval will be 95%. So in my case, you can see I took only 68 samples, but it's 98.5% in this case, right? The second thing, let me get back to 3, the standard deviation equal to 3. The second thing that can actually change the size of your confidence interval, it's the sample size. The idea is very simple. The smaller sample size, the more far the sample mean can be from the population mean. So by increasing sample size, we also decrease the confidence interval. You can see that the sampling distribution gets more and more narrow, and then if your sample size is 40, you can see that also you have some extreme values here, but in the majority of values it's around the true mean, and then you can see that the population mean and the sampling mean are pretty close. And again, if I start taking a lot of samples, after a while you will see that I have approximately 95% within, and then approximately 5% will have mean outside this interval, outside the shaded area. But once again, you can see that the area is very small, so it's between 99 and 101, right? So every time you take a new random sample from your population, the mean of this sample is a random value. It varies around the true population mean, and then you can compute the limitations of this variation, so the kind of interval of this variation, how far the sample mean can go, and that's what we call a population-based confidence interval.